right? Step number 1, we want to use Laplace transforms to solve ordinary differential equations. So go to the differential equation and take the Laplace transform of every term. So number 1, take Laplace transform in both sides of the ordinary differential equation. Step number 2, enter the initial conditions, if there is any. Remember, initial conditions may involve the function, the 0th derivative of the function, that means the function itself, or derivatives of order 1, 2, and 3, depending on what is the order of the ODE. Could be that the ODE has order 3, which means the initial conditions would involve the second derivative, first derivative, and the 0th derivative, and so on. Step number 3. Solve the equation. So once the ODE has been transformed, step number 1 will be switching from time domain, assuming the time is the independent variable, from the time domain into frequency domain, which is the domain for the new expression, typically written with capital letters, right? So now in that frequency domain, we have an algebraic problem. So step number 3, solve the equation algebraically for the transform x, capital X of S, the transform capital X of S of the unknown function little x of t. So little x of t is a function of, with a function defined in the time domain. Capital X or big X of S is a function defined on the frequency domain. And what we want is to solve for big X. In the last step, here's step number 4, we go backwards. Invert big X of S to find little x of t. So that's the step. The last step is the step in which it is required to use the inverse Laplace transform. We use it at the beginning, switch from time domain to frequency domain, solve an algebraic equation, and then use it again at the end to go from frequency domain back to the original time domain. And it's that step number 4 that requires, typically, could be more sophisticated, but it's the step number 4 that requires what's this? Zooming in. Very good. Requires this information, right? Information on functions here. Say t to the n, right? They're not seeing anything there. Information on function powered of t and the nth power, and its Laplace transform being this. So when we're going backwards, we're assuming that we know this Laplace transform, so we recognize some type of pattern, and we try to go back to the original function. So that's why this column is expressed in terms of S being an independent variable in the frequency domain. However, the first column is expressed with things that are in terms of t, the independent variable in in the time domain. So at that fourth step, we are meant to use this table. We've been talking about this quite a little bit, so let's work an example to illustrate steps 1. Right, so we have 4 steps. Take Laplace transform on both sides, use initial conditions, solve algebraically, then take Laplace, inverse Laplace transform. So